Hi, everyone, and welcome to Distance Learning for today. We're finishing up the lecture that we started with the lab that looks at how do we identify individual differences between people, right? There's a lot of different reasons why we do this. There's a lot of different aspects of sports and skill and life that look at how do we determine what makes one person different from the next, right? Because if we're trying to identify this, we start this at a really early age. We're trying to identify what might make someone stand out at a particular skill, a particular ability, and especially now with sports specialization and things like that, we're even trying to find out how early we should start kids at a certain sport, when they should specialize. I'm not a big proponent of that, but there are even places around the world and around the country that are looking at individual differences from a standpoint of genetic testing and trying to find the athletic gene and looking at muscle biopsies to try to determine fast twitch and slow twitch muscle fibers. And based on those determinations, we can steer people in the right direction of what sports they can possibly play. And without knowing it, you guys have, even from a college admission standpoint, participated in a huge correlational study, right? Bethel University and universities around the country use tests like the ACT and the SAT to try to see what sets people apart one from the next. And schools have set certain standards based on ACT scores or SAT scores that give them an idea of potential future success at college rigors, right? So based on your score, whether that's 17, 21, 27, 31, 35, right? Schools can make a determination based on what that score is and give them an idea of who's going to potentially be able to provide them tuition over the course of a 4-year career. So academically, from a sports standpoint, we're always trying to find out what sets one person different from the next. And there are a lot of different approaches that look at that, right? We've got the experimental approach that can take a look at, all right, experimental approach. We want to take all of our graduating seniors and see what their GPA was in Intro to Psych or looking at CWC. And based on those scores, we can say, yeah, if you got this grade in that particular class, those people have a higher retention rate, right? So the experimental approach takes a look at one homogeneous group of individuals and then studies them. The differential approach takes a look a little bit differently, and is what we did with this particular lab. Is it takes a look at a large group of individual and a large range of data and tries to find relationships between what makes people similar, what makes people different. Can we find relationships between two data points? This is a big business, right? Even with the NFL draft coming up, the Combine does this exclusively looking at data points. And they've determined certain tests that can be a determination of someone's potential success. So we can take an offensive lineman and say arm length. We want their arm length to be a certain length to show that they are going to be a successful left tackle, or a defensive back, a cornerback. They need to be able to run a 40-yard dash or have a 3-cone shuttle that falls within a certain range. And based on those scores, we can say, yeah, historically, those individuals need to have a certain score to make a determination on their potential success in the NFL. So when we look at this, when we look at these studies, it's really simple to do this. And I'm going to show you guys how to do this on an Excel spreadsheet in a couple of minutes. One of the ways we do that is by doing what are called correlational studies. And correlational studies are a really simple statistical analysis where you can take any two sets of data, whether that's reaction time, whether that's shoe tying time, whether that's visual acuity. If we can put a number on it, we can do a correlational study. And then we can try to find relationships between that data, right? So with you guys, with your balance test, we took a look at 4 different balance tests, dynamically and statically, if those are words. We look at dynamic balance and static balance, and based on those, we can measure that against a physical characteristic and say, is there a relationship between a physical characteristic of foot area and see if that makes someone better at balance, right? Because it should, right? If someone has a bigger foot, it gives us more sensory information. If they have a wider base of balance on their feet, then their balance scores should be significantly higher if they have a larger foot. Now, that may not always be the case, right? If we look at USA Gymnastics and women's gymnastics or men's gymnastics, those individuals are usually smaller in stature, smaller in size. So how does that play in? We need to look at a lot of different data points with physical characteristics that might be a better determinant of overall balance that could potentially show that they have a future in gymnastics. Let me give you an example. So when I was working in professional basketball, one of the things that the NBA did was that they wanted to try to find determinate physical characteristics, to try to find relationships between certain physical characteristics and success in professional basketball. So one of the things that they did was that they took a look at wingspan. Now, for the majority of us, when we take a look at wingspan and we measure you middle finger to middle finger with your arms out, that ratio is about a 1-to-1 ratio with your height. Well, we took a look at a lot of different players in both the NBA Developmental League and in the NBA, looked at their wingspan, and then looked at things like shooting percentage, free throw percentage, length of NBA careers to try to find whether or not there is a relationship between wingspan and NBA success. And let me show you what that looks like when we talk about correlations, and we'll start getting into the numbers. So if we take a look at it and we make this graph, we'll give this a little bit of time. I know the lighting in here takes a second to adjust, and I'm going to try to talk loud enough that the microphone picks me up. So if we take a look at it and we put wingspan on the bottom, and we put basketball skill at the side, and whatever number that is, again, somewhat arbitrary, and we were to take a look at wingspan, is that when they took a look at this data, that it showed that the greater your ratio was above that 1, that was a pretty good indicator of success in the NBA. So if we were to take and draw a line of best fit, which you guys did at your last experiment with the tapping task, and we were to bisect all of these data points, we could show that we would see a pretty good trend in the relationship between wingspan and basketball skill. Statistically, when we take a look at this, what we're doing is that we're trying to find R values based on correlation. Now, when we talk about correlation, we're looking for directionality and we're looking for strength of the relationship. Directionality is this line, right? So if we were to say that, or take a look at this particular study, we would say this line goes up and it goes to the right. That's a positive correlation, right? Because as one value increases, the other value increases as well, right? So we have directionality. If we have directionality, that means as one value increases by a factor of 1, the other value increases by 1, right? So we have directionality. This is a positive correlation. Now we talk about positive and negative correlations. That doesn't mean good or bad, right? It's just directionality. The good or bad when we talk about a relationship is based on the value that we get. And when we look at correlations, the correlation values that we get statistically are on a scale of -1 to 1. The stronger the relationship, the stronger those values are to -1 and to 1. If we were to see a really strong positive correlation, we would want that value to be as close to 1 as we possibly can. Now, if we're doing an actual scientific experiment, we would set that value at 95%. So we would want to see a 0.95 value to show that there's a really strong relationship between these two sets of data. So this particular study would show a strong positive relationship between wingspan and basketball skill. Now on the flip side of that, as we draw a new set of data, one of the other characteristics that they measured was that they wanted to try to understand why certain positions shoot better free throws than other positions, right? You have your point guards, your shooting guards, your smaller players are really good free throw percentage shooters. Centers, not so much. Your Shaquille O'Neals, your Dwight Howards, those guys, even though they've probably shot as many free throws as the smaller guys, what sets them apart as far as why are they not as good at shooting free throws? So when they took a look at the data, and we draw that back up here, and we were to put finger digit span looking at thumb to little finger with your fingers spread out, and free throw percentage, if we were to take a look and graph this data, we would see something that looked more like this, right? So your Shaquille O'Neals of the world, really big hands, really low free throw percentage. And if we were to draw a line of best fit through this set of data, we'd see a line that looked like this. Now again, when we're doing correlational relationships, we're looking at directionality. This one goes down and to the right, that means we have a negative correlation. Now again, just because we have a negative correlation doesn't mean that that's bad. This is actually really good. If we were to have a data set that looked like this, we'd say that there's a negative correlation, but it looks pretty strong, right? Because as one value decreases by a factor of 1, as one value decreases, the other value increases. So as one number goes up, as finger digit goes up, your free throw percentage goes down, right? That's a negative correlation. It gives us directionality. Now again, in this case or this instance, if we were to look at this statistically, we would see that this number on this scale would fall closer to that -1, right? That gives us the strength of our relationship. So a negative number that's closer to -1 is a strong relationship as well. It's just a strong negative relationship, meaning it's a very strong relationship, We see that there's a connection between these two sets of data, but the directionality just means that as one value increases, the other value decreases. So let's take a look. I'm going to go over to the computer screen. I'm going to pop this up here. I hope you guys can see this fairly well. We'll get rid of this data on the screen. And we'll take a look at this from the data set that you guys have. So I'm going to go off screen. I'm going to go to the computer. I'm going to talk really loud. I apologize if it sounds like I'm yelling on YouTube at you guys right now, but we'll try to get this done the best that we possibly can. So this is your data set that you guys provided for me, right? So we have all of our things here. I took out the rank scores. We're not going to worry about the rank scores now. It's something that's going to be, that would take a little bit of a deeper conversation or a deeper dive into when we're looking at these particular relationships. So we'll just leave that out for now, and we may touch on that a little bit later on in the semester. But if we were to take a look at a couple of your scores, right? We got your physical characteristic here, and I've manipulated this a little bit just to kind of put some columns next to each other so it's a little bit easier to see. So if we take a look and we do this on Excel, and we were to take a look at your physical characteristics, this is the way that we would statistically analyze this and give us an R value based on a correlational study. So if we're in Excel, and we go up here to data, sorry, it's a little bit different on this one than on my computer. So this one's under formulas. If we go to formulas, more functions, statistical, and down here under the statistical category, we've got CORREL, right? That gives us our correlational value. So it highlights a cell down here where we're going to get our value. And if we click on this arrow right here, it allows us just to drop down and highlight this entire set of data. So we have all of our physical characteristics of you guys with your foot area size right here. We go back, click this area, and now let's compare that to your ankle touch scores, right? So we're going to take this and look at physical characteristics and ankle touch and try to find out if there's a relationship between those. We click on OK. We have our value right down here, right? So our value with our correlational study is a 0.57. And it's positive, meaning there's a positive relationship between our physical characteristic and our ankle touch. Now, again, we're looking at directionality with a positive value. But we also want to talk about the strength of this relationship. Now, we got a 0.57. Now, it might not look like much as far as what that is with a 0.57. We want that number to be closer to 1 to give us a strong correlational value. But with our sample size and with our limited differences probably between how big your feet are, right? This is a pretty good value, right? So you guys actually got a pretty good score with your physical characteristic and your ankle touch. We have a pretty strong relationship between these two sets of data, all right? With 0.57, it's getting closer to 1. We're a little bit more than half, but we would probably be able to make a conclusion based on this, that based on this set of data, if we were to take a bigger or wider range of individuals, study maybe 100 people based on this particular test, we might see that value increase or get closer to 1 even more. So we have this value, so it gives us directionality. We have a positive relationship between these two sets of data. If this were negative, remember, it doesn't change the fact that it's a good or bad relationship. It just means that it would be a negative relationship between our physical characteristic and our ankle touch. So let's take a look at that visually, and we can see. So another great thing that Excel does is that we can take and do a quick graph of this. So if we were to take and highlight both of these sets of data, we can make a really quick graph, a scatter plot graph that you guys did on paper, sort of building on that last lab that you guys did. If we go to insert, we go to charts, go down here to the scatter plot, we can actually, take, and I'll move this over here, and we can see your data laid out visually, right? So this is a little bit harder to see as far as just seeing that. We only have a limited number of data here, but we can take and add a quick chart element on there. We can put a trend line on there, and we can see what that looks like, right? So we have that relationship that goes up and to the right and gives us an idea of exactly what that relationship looks like. So really simple and really easy when we look at that, and we'll give a second for the light to readjust to me. If you guys are looking to do senior research, you can take any two sets of measurable data and try to find relationship between those two values. So if you want to find out whether or not someone with, So just to give you an example of some studies that we've done in the past, we've taken a look at things like external rotation. If we look at the external rotation of all of the pitchers on our baseball team and looked at their max velocity when they're throwing a fastball, we can try to find a relationship between those two sets of values, right? So if we see a positive relationship between external rotation and fastball velocity, we could say that if we increased someone's external rotation, we could increase their velocity because we found a relationship between those two sets of data, right? So correlational studies are a great way to find individual differences between people. All you have to do is be able to put numbers on values, and right, if we have data sets and we have two sets of data, you can easily throw that into an Excel spreadsheet, get a value that shows directionality, give you a value that shows strength, and then we can make conclusions based on a really simple number and a really easy answer that we get just by doing some easy statistical analysis. All right, finishing up that lecture. Really quick, the exam that we have set up for today, I'm going to put that up on Moodle. You guys have until Wednesday to get that done. You guys can use all the resources that you have available to you. Use your notes, use your book to go through that. I'd prefer that you guys did that by yourselves. But again, in the climate that we're in, I'm not that worried if you reach out to each other. I don't want a big group test, but use all the resources that you have available to fill out that exam, to get that exam finished. It'll be due on Wednesday. That'll be up on Moodle. The next lab that starts the third unit, you guys will get that on Monday. Have a great weekend, you guys. Stay safe, stay healthy. Enjoy the time that you have with your families, your friends that are close by with as much social distancing as we possibly have. Take care. We'll talk soon.